Okay, so I want you to remember back to Calc 1 when we talked about first derivatives and second derivatives. Remember, the first derivative of a function f measured the increasing and decreasing of a function, and the second derivative gave us information about the concavity of a function. So I want to come up with sort of an analogous function for multivariable calculus. And so the way that we'll do this is that we'll define second order partial derivative. So a second order partial derivative of a function f is one that's a partial derivative of a partial derivative. So it's a partial derivative of fx or fy. Now, we have two directions to go in this, right? We can take the second derivative with respect to x, so a partial fxx. We can take a partial of fy with respect to y, or we could take mixed partials. So fx, take a partial of that with respect to y, or take a partial of fy with respect to x. So these are the definitions. So fxx is notation that I'll use to mean first take a derivative of with respect to x of my function, then take a derivative of that with respect to x again. Fyy will be first take a partial with respect to y, then take another partial with respect to y. Fxy will be first take a partial with respect to x, then take a partial of that function with respect to y, and finally fyx will be first take a derivative, a partial with respect to y, and then a partial with respect to x after that. So we'll do an example of this just to flesh out what these mean. But maybe a nice geometric interpretation, nice graphical interpretation is in order here. So remember, fx represents or gives us the slope or the instantaneous rate of change or the increasing, decreasing of, well, what is it? So really, I'm fixing y and I'm going just in the x direction. So the increasing, decreasing of the intersection of f with a plane parallel to the x or the yz plane. Fy represents the increasing, decreasing of a plane to the of the intersection of f with the xz plane. So if I have some function, for example, maybe a picture is in order here. If I have some function, like maybe this paraboloid, and I intersect this with a plane, then what I'll get is just a curve. And so the increasing, decreasing of this curve, if this is a plane parallel to the yz plane, fx will tell me the increasing, decreasing of this. Fy will represent the increasing, decreasing of if I'm talking about in a direction parallel to y. So what does fxx represent? Fxx represents concavity of the intersection of f with the plane parallel to the xz plane, to the yz plane. And fyy reps the concavity of the intersection, again, of this time f with a plane parallel to the xz plane. Again, it would be really nice to see GeoGebra on this, since it's very difficult to actually draw these things. But if I think about intersecting this plane with my curve, fxx will tell me the concavity of this curve, and fyy will tell me the concavity if I look at the curve in strictly the y direction. Fxy and fyx are a little bit more subtle, so I'll reserve these for a future discussion, what these represent. But we'll be using these today for something, and I'll try to maybe next class explain why and what they are.